Small a, small b, small c, small d are the elements of the set, whereas capital A, capital B, capital C will represent a set. Okay. So in general, a set is nothing but a collection of well-defined objects. Q is the set of all rational numbers, so which is nothing but Q is equal to P by Q, such that P and Q belongs to any integer and Q is not equal to 0. A set can be represented by two methods, that is, one is called the tabular method, or it is also called as the roster method, and the second one is called as the set builder method. Hello dear students, welcome to this session of Discrete Mathematics class of second semester BCA of Mysuru University. I am Mr. Niranjan, faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in this session I am going to discuss regarding the very important chapter in Discrete Mathematics for second semester BCA. That is, in that first unit we are going to study the basic structure. So the first unit contains the detailed syllabus for the first unit, or actually you have 3 units in your syllabus. Each unit contains 20 marks. So the weightage for this unit 1 is 20 marks, and here the first chapter is basic structure. So in the first unit we are going to study regarding the basic structures of sets, different types of sets and construction of the sets and the operations on sets. Similarly, functions, different types of functions, and then sequences, sequence and series, summation, sums and the matrices. So that is addition, subtraction, multiplication of matrices, as well as sets operations like union of sets, intersection of sets, difference of sets, complementation of sets, and similarly the functions, construction of the functions and different types of functions like one function and onto function, and then the sequences and the summation, sequence and summation of series and the sequences, and also in detail the summation of the matrices. So very simple chapter and very important unit indeed. So this will fetch us around 20 marks in your examination. Okay. Now the very important concepts are sets and the construction of the sets and the operations on sets, as well as the matrices. So that is definition of matrices, different types of matrices, and the operations on matrices like addition, subtraction, scalar multiplication, matrix multiplication. So these are the things which we are going to study in this unit number 1. Now let us come to the first concept, that is set theory. Let me explain the set theory. Now what is a set? You know, set, wherever you go we are going to use the concept of set. Set generally represents the collection. What collection? Collection of well-defined object. The collection of well-defined object is called a set. Whatever may be the collection, either it may be numbers or elements or things. Just a collection of well-defined object is called a set. For example, set of all natural numbers less than 10, set of all even numbers less than 10, right? Or set of all capital cities in India, set of all capital cities in India. Okay. So like that, different collections can be put in form of a set. So here the German mathematician Mr. G. Counter introduced the concept of these sets. So this set theory forms the basic for several other fields of study like counting theory and relation, graph theory and finite set mechanics. So this helps to study the different fields like counting theory, relation, graph theory and finite set mechanics. All these concepts are studied with the help of these sets. Now let us come to the, as I told, the definition of a set. A set is a well-defined collection of distinct objects. A set is a collection of well-defined distinct objects. So for example, let us consider a set. A is equal to A, B, C, D. This is a set. Here the set contains the alphabets from A, B, C, D. Now usually a set is generally represented between the two flower brackets or between two small brackets, and the capital A, capital B, capital A, capital B and capital C denotes the sets, whereas small a, small b, small c, these are all called as the elements of the set. Small a, small b, small c are called the elements of the set, whereas capital A and capital B, capital C will represent the set. Now here, suppose if any element A is included in the set, means A belongs to A. Now let us take one more element. Let us take C. So C belongs to, C is an element of A is denoted as C belongs to A. Similarly, D is also an element which belongs to A. So here these A, B, C are the elements or numbers of the sets. They are also called as the elements of the set. Small a, small b, small c, small d are the elements of the set, whereas capital A, capital B, capital C will represent a set. Okay. So in general, a set is nothing but a collection of well-defined objects. A collection of a well-defined distinct object is called a set. Okay. Now, next come to the next concept, how to construct a set. So, before that, let us know some standard representation of the sets. So, some of the important set, as you might have been studied in your previous classes, the set of natural numbers, that is, the set of all counting numbers forms the set of natural number and it is denoted as n. N is set of all natural numbers, all counting numbers, all positive numbers, 1, 2, 3, 4, 5, 6, etc. They are all called as natural numbers. So, the set of natural number is denoted as n, which contains all the counting numbers like this, 1, 2, 3, 4, 5, 6, etc. Next, the set of integers. The set of integers is denoted as I or Z. I or Z will represent the set of integers which contains 0 as well as all positive and negative numbers, positive and negative integers. So, the set of integers is denoted as I or Z which contains 0, 1, 2, 3, minus 1, minus 2, minus 3. So, therefore, 0 plus or minus 1 plus or minus 2 plus or minus 3 etc. all comes under the set of integers and it is denoted as I or Z. Now, the set of all positive integers is denoted as Z plus. Z plus is nothing but all positive integers. All positive integers 1, 2, 3, 4 etc. They are all under this set. Okay. Now, let us come to the set of all rational numbers. The set of all rational numbers is denoted as Q. Q is the set of all rational numbers. So, which is nothing but Q is equal to P by Q such that P and Q belongs to any integer and Q is not equal to 0. P and Q are any integer, either it may be positive integer or negative integer, provided the denominator is not equal to 0. So, the set of all rational numbers is denoted as Q. Q is equal to P by Q, where P and Q belongs to any integer and Q is not equal to 0. Now, the set of all real numbers is denoted as capital R. So, set of all real numbers, which is a union of all these natural numbers, integers and rational numbers, comes under the set of real numbers and it is denoted as capital R. And whereas the set of all whole numbers is denoted as W. So, W is the set of all the whole numbers. Now, these are all some important sets, the representation of the. So, generally we are going to represent some important sets like these capital letters N, Z, Z plus, Q, R and W. Suppose if you have a complex number, the set of complex numbers is denoted as C. C is the set of complex number, where R is the set of real numbers, right. So, these are general representation of sets. Now, the question is how to form a set. So, the formation of a set. So, here since before that, let us know regarding the cardinality of the set. Actually, the cardinality of a set will represent the number of elements present in that set. The number of elements present in the set will gives the cardinality. So, cardinality of a set is denoted by n of s, number of elements in the set. This is the number of elements of the set. The number of elements of the set is also referred as the cardinal number. Suppose if a set has finite number of elements, then the cardinality is finite. Suppose if it has infinite number of elements, then the cardinality of infinite set is infinity. is infinite. Now, here let us consider an example. Let A is equal to 1, 4, 3 and 5. These are the elements of the set. Since this set contains n is equal to number of elements is 4. So, therefore, the cardinality of this set n of A is equal to 4. This contains 4 elements. So, here cardinality refers to the number of elements present in the set. The number of elements present in the set is called the cardinality. Here the set A contains 4 elements. Therefore, n of A is equal to 4. Similarly, let us come to the second example. Here B is equal to 1, 2, 3, 4, 5, 6, etc. infinite. Since there are infinite number of elements in the set B, so therefore, the cardinality of the set B is equal to infinity. If the number of elements are finite, then we are going to get the finite number as the cardinality. If the number of elements are infinite, then the cardinality of that infinite set is infinity. So, these are the examples for cardinality of the set. Now, let us take one more set. Let A is equal to 2, 4, 6. This contains 3 elements and therefore, the cardinality of this set is 3 and it is denoted as n of A is equal to 3. The number of elements in the set A is equal to 3, that is the cardinality. Okay. Now, you got an idea. So, the number of elements in the set is nothing but the cardinality of the set. So, if a set contains finite number of elements, then the cardinality is finite. If it contains infinite number of elements, then it is called then the cardinality is infinite. Now, let us come to the very important concept now, that is the representation of a set, construction of a set, representation of a set. So, a set can be represented in 2 ways, that is roster, or it is also called as a tabular form, and the second one is called the set builder form. The first one is called as the roster form or tabular form, whereas the second one is called as the set builder form or set builder notation. These are the 2 types, 2 ways to represent the set. So, a set can be represented by 2 methods, that is one is called the tabular method or it is also called as the roster method, and the second one is called as the set builder method. Now, let us come to the first one, roster method, or it is also called as tabular method, roster or tabular form. So, in this roster form, all the elements of the set are listed. If all the elements of the set are listed and the elements are being separated by the commas and are enclosed between the 2 flower brackets like this, between the 2 braces, then the set is called the roster form. That such a form is called as the roster form or it is also called as the tabular form. So, in roster form or tabular form, the elements of the set are listed and they are separated, each and every element are separated by the commas and they are enclosed between the 2 flower brackets. So, let us consider for example, the set of all vowels in an English. Set of all vowels, as you know, the set of all vowels is A, E, I, O, U. A, E, I, O, U is the set of all vowels, which is an example for the set in the roster form. Other example, let us consider one more example, that is the set of all odd numbers less than 10. Set of all odd numbers less than 10 is also an example for the roster form, that is B is equal to 1, 3, 5, 7 and 9. Right, this is an example for a set in roster form. Let us take one more example for this tabular method. Let us take another set C. C is equal to set of all even numbers less than 10. Less than 10. Set of all even numbers less than 10 means that is nothing but C is equal to even numbers 2, 4, 6, 8. Less than 10 is up to 8. Or if one more example, set of all even numbers less than or equal to 10 means we can write 2, 4, 6, 8 and 10. So, this is how we are going to represent a set in roster form. So, in roster form, all the elements of the set are listed and the elements being separated by the commas and are enclosed by the flower bracket. So, these are few examples for the sets in roster or tabular form. Now, let us take one more example. So, before going to the second one, let us take one more example. List the elements of the following set in the roster form. So, let us take an example. List the following elements in the roster form. The set of all positive integers which are multiples of 7. Now let us take another example for the roster form. Set of all positive integers which are multiples of 7. So the multiple of 7 are nothing but 7, 7 into 1, 7 into 2, 7 into 3, 7 into 4, like that. So the set of all positive integers which are multiples of 7 in the roster form is denoted as, say, a set A is equal to 7, 14, 21, 28, etc. This is an example for the elements of the set according to the given condition. Okay. So this is an example for the set of all positive integers which are multiples of 7 in the roster form. Now let us come to the next second type, that is called as the set builder form. Set builder form. So in this form, the characteristics property possessed by the elements of the set are written in the form of the description in the curly braces. That means here the elements of the set are listed or written according to the given statement or given definition. The elements of the sets are listed according to the given statement. So in set builder form, the elements of the set are listed according to the given statement or according to the given definition, according to the given condition. So the elements of the sets are listed according to the given statement. Let us consider, for example, if A is equal to X such that X is an vowel in an English alphabet. X is an vowel. So what we are going to write, A is equal to X such that X is a vowel in English alphabet is an example for this set builder form. What are the elements we are going to get? Usually we are going to get A, E, I, O, U. These are the elements which we are going to get from the statement. So that is, X is a vowel in an English alphabet is an example for a set builder form. So if you write the elements of the set, you are going to get the values as A, E, I, O, U. Now another example, X such that X is less than 6 where X belongs to a natural number. X means all the elements of X which are less than 6 is an example for this roster. So if you write the elements, what are the elements you are going to get here? All the natural numbers. X less than 6 means you will get 1, 2, 3, 4 and 5. These are the elements of the set. So here the elements are listed according to the given statement. What is the statement given? X such that X is a vowel in an English alphabet means all the vowels A, E, I, O, U comes under this set. Similarly, another example, X such that X is a natural number which is less than 6 means 1, 2, 3, 4, 5. Another example, let us take another example, see X such that X belongs to N, X such that X belongs to N and X is a natural number which is less than or equal to 5, which is less than or equal to 5. Which is less than or equal to 5 in the sense you will get the same elements 1, 2, 3, 4 and 5. Less than or equal to we have taken 5. Here less than 6, therefore we have taken up to 5. So these are few examples for the sets in set builder form. Now hope you got an idea what is a set and how to construct a set, that is using first one is the roster form, another one is the set builder form. Now let us take few examples. Based on this, let us take a problem. Write the solution set of the equation x square minus 16 is equal to 0 in the roster form. Well, according to the definition, what is a roster form? Roster form is nothing but, here roster form, the elements of the following set is, that is roster for all the elements of the set are listed and being separated. So all the elements being listed in the roster form. If you solve, you will get the elements. So here what is given? X square minus 16 is equal to 0, x square minus 16 is equal to 0, x square is equal to 16, x is equal to square root of 16, that's equal to plus or minus 4. So write the solution set of the equation in the roster form. Since there is no condition like natural numbers or real numbers, we can write the elements of the set as A is equal to, it contains minus 4 and plus 4. Suppose only the natural numbers means A is equal to 4 you will get. If it is an integer means minus 4 and plus 4. Now, let us come to the second example. What is the second problem they are given? Write the set A is equal to 2, 4, 6, 8 in set builder form. So, the elements of the set are given. We have to write the statement for this. If you observe carefully, write the set A is equal to 2, 4, 6, 8 in the set builder form. So, here the elements of the set are given. What is to write is the statement for this set. So, that is nothing but A is equal to, if you observe carefully, this is x such that x is equal to 2n, x is equal to 2n. This is nothing but multiples of 2, 2 into 1. So, 2 into 1, 2 into 2, 2 into 3 and 2 into 4. So, 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8 are the elements. So, according to the given elements, this can be written as 2 times n, where n belongs to a natural number and n is less than or equal to 4. Here n is less than or equal to 4. Less than or equal to 4. So, that is x is equal to x such that x is equal to 2n, where n is a natural numbers and n is less than or equal to 4. If n is equal to less than or equal to 4 means 1, 2, 3 and 4. If you put n is equal to 1, 2, n is equal to 2, you will get 4, n is equal to 3, 6, n is equal to 4. Or you can also write, you can also define this as A set A is equal to x such that x is the set of all even numbers, set of all even numbers less than 10. Set of all even numbers, set of all even numbers less than 10. Set of all even numbers are 2, 4, 6, 8 less than 10. Set of all even numbers less than 10. You can also put it in this form. So, depending upon the problem, you can write the solution. That's it. Now, let us take the next example. Represent the following set in the set builder form. So, represent the following set in a set builder form. What is the set given? X is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. What is this set actually? This is nothing but the set contains all the days in a week. So, x is equal to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday and Saturday is nothing but the set containing all the days of a week. Hence, the set in the set builder form can be written as x is equal to x such that x is a day in a week. X is a day. This x is nothing but a day in a week. Now, let us come to the next types of set. The very important concept is the types of set. Now, what are the types of sets? So, empty set. First one is an empty set, or it is also called as null set, or it is also called as a void set. Empty or null set means it does not contain any element. That's it. So, a set which does not contain any element is called a null set or a empty set. Now, usually a null set is denoted like this, pi. The general representation of a null set is pi. So, we are going to represent the null set like this or null set like this, pi. Pi is the representation of a null set. So, a set which does not contain any element is called the null set. A set which does not contain any element is called an empty set, or it is called as a null set. So, or a null set or void set, and it is denoted by the letter pi. Read it as pi. This is a null set, or we can also write an empty set like this. These are all the representation of a null set. In roster form, null set is denoted by the flower brackets like this. Null set, nothing is there inside this set. Now, let us come to an empty set. An empty set is said to be a finite set since the number of elements are finite. Finite set. Finite set means a set which contains definite number of elements is called a finite set. So, an empty set is a finite set since the number of elements in an empty set is finite, that is 0. Now, for example, the set of whole numbers less than 0 is an example for a null set. The set of all numbers which are less than 0 as a whole number is an example for a finite set. Or if you want, you can take one more example for a null set. The set of all whole numbers less than 0 is an example for a null set or an empty set. Or the set of all triangles in a plane such that the sum of the three angles is greater than 180 degrees. Sum of three angles is greater than 180 degree is an example for a null set. Okay. Let us take one more example. If A is equal to, if A is a set of all natural numbers less than 4 which is exactly divisible by 5, all natural numbers x belongs to n and n is less than 4 divisible by now I will write the elements of the set are A is equal to n such that n is less than 4 means all natural numbers less than 4 means 1, 2, 3. So which are divisible by 5. 1 cannot be divisible by 5, 2 cannot be divisible by 5 and 3 cannot be divisible by 5. So this is also an example for a null set or an empty set. Okay. A set which does not contains any number, this is called a null set and it is denoted like this. Okay. Now let us come to the next one, singleton set. Single means one. A set which contains only one element. Singleton means what? A set which contains only one element is called a singleton set. Okay, just one element, that's it. So, a set which contains only one element is called a singleton set. So, denoted as like this. This is a representation of a single set. Now, here, for example, x is neither prime number or composite number. There is 1. So, x is neither prime number nor a composite number. It is a single set containing one element, that is 1. 1 is neither prime number or a composite number. So, this is an example for a singleton set. Okay. A set which contains only one number, one element is called as a singleton set. Now, let us come to the next type, that is finite set. Finite set means if a set which contains definite number of elements, finite number of elements, a set which contains finite number of elements is called a finite set. A set which contains definite number of elements is called a finite set. Empty set is also called a finite set. Now, let us consider for examples the set of all colors in a rainbow is an example for a finite set because it contains 7 colors. X belongs to n and x is less than 7. So, therefore, A is nothing but set of all colors, 7 colors, Vidhyaashram. What we are going to get the 7 colors, Vidhyaashram is an example for the finite set. Or let us consider one more set, A is equal to 5, 7, 9, 11. This is also a finite set since the number of elements in the set A is n contains 4 elements. 1, 2, 3, 4 elements. Another set B is equal to 4, 8, 16, 32, 64, 128. This is also an example for a finite set. The number of elements in the set is 1, 2, 3, 4, 5 and 6. So, these are example for a finite set. Finite set means a set which contains definite number of elements 1, 2, 3, 4, 5, 6, 7, 8, 9. This is also an example for a finite set. Another set for example, if you take B is equal to A, E, I, O, U. This is also a finite set because it contains definite number of elements. Now, the next one is an infinite set. Infinite means a set which contains infinite number of elements. There is no definite number of elements is called an infinite set. A set whose elements cannot be listed. The set containing never-ending elements is called an infinite. So, in general, a set which contains infinite number of elements, a set having infinite number of elements is called an infinite set. Let us take an example. If A is equal to set of all natural numbers 1, 2, 3, 4, 5, etc. This is an example for an infinite set because the cardinality of this set is infinity. N of A is equal to infinity. Let us take one more example. B is equal to set of all integers plus or minus 1, plus or minus 2, plus or minus 3, etc. This is also an example for the infinite set. Since the number of elements are infinite, never ending, this type of sets are called as a infinite set. So, in general, finite set means a set which contains finite number of elements is called a finite set, whereas a set which contains infinite number of elements is called as an infinite set. This is a very important concept indeed. since in your syllabus you are going to study the basics, that's it. It's a basic concept. The concepts we are going to study is only the basics like a definition, construction and the few problems based on the operations, right? Now, let us come to the next one is equivalent set. Equivalent sets. So, two sets A and B are said to be equivalent if the number of elements in the sets are equal. If the number of elements in two sets are equal, then they are called as equivalent sets. That is, if their cardinal numbers are same, that is number of elements in set A is equal to number of elements in set B, then the two sets are said to be equivalent, and symbolically we are going to represent like this equivalent set. Now let us consider, for example, A is equal to 1, 2, 3 and B is equal to PQR. The number of elements in set A is 3 and the number of elements in set B is 3. So A is equal to B, denoted as A is equivalent to set B. Now let us take one more example. Let us take P. P is equal to A, B, C, D. Another set Q is equal to X, Y, Z and L. Here the number of elements in the set A is set P. N of P is equal to Q. N of Q is also equal to. So N of P is equal to N of Q. Number of elements in set A is equal to number of elements in set Q. So the cardinality of the both sets are equal. Therefore, these two sets are called equivalent set and it is denoted as P is equivalent to Q. These two sets are equivalent sets. So, important definition, two sets are said to be equivalent if the number of elements in set A and set B are equal. Number of elements, if the cardinality are equal, then they are called as equivalent set. Suppose if the number of elements are same and the elements are also same, then let us come to that one. So, equal sets. So, equal sets means two sets A and B are said to be equal if and only if they contain same elements and every element of A is an element of the B. That means, if the number of elements in both the sets are equal and same, then the two sets are said to be equal sets. If the number of elements are same and the elements are also same, then the two sets are said to be equal sets. So, let us take an example. If A is equal to P, Q, R, S, another set B is equal to P, R, same P, Q, R, S, just we have changed the order. Whatever may be the order, the place of element of a set, but the number of elements in the set and the elements of the set must be same. So, since A contains P, Q, R, S, B also contains P, Q, R, S, but we have placed in different places. Therefore, the two sets A and B are said to be equal. Let us take one more example. If I take C is equal to 2, 4, 6, 8. Another set D is equal to 6, 8, 4, 2. This is also equal set because the number of elements in set A is 4, the number of elements in set B is 4. So, number of elements are same and this contains 2, 4, 6 side, this also contains 2, 4, 6 side. Therefore, we can represent them as C is equal to D, that is C is equal to D. So, the number of elements in C is 4 and the number of elements in D is 4. So, if I represent this as A and B, I will get N of A and N of B. Since we have represented it as C and D, so N of C is equal to 4, N of C is equal to 4 and N of D is also equal to 4. These two are equal. So, these two sets are said to be equal. So, in general, if all the elements of the set are equal and same, then if two sets will have the same elements and the number of elements are also same, then they are called as the equal sets. That's it. Now, let us come to the next very important concept, subset. Subset means let us consider a set. So, let me take one set. If B is equal to 1, 2, 3, 4, 5, 5. This is a set. Another set A is equal to 1, 2. Another set C is equal to 3, 4. Now, what do you say from this? All the elements of A must be the elements of set B. All the elements of C are the elements of set B. Similarly, all the elements of set C is also the element of set B. That means all the elements of A are the elements of set B, all the elements of C are the elements of set B. That means A is a subset of B, C is also subset of B. That means this is denoted as A is the subset of B and C is the subset of B. So this is how we are going to represent a subset. So how to define a subset? If each and every element of a set A is also the member of the set B, then the set A is called the subset. That means here each and every element of A are the elements of set B, therefore A is a subset of B. If all the elements of set A is an element of the set B, then A is called the subset of B. If all the elements of the set C are the elements of set B, then C is called the subset of B. So if each and every element of a set A is also a member of the set B, then the set A is called the subset. Now let us take another example. If A is equal to 1, 2, 3, B is equal to 1, 2, 3, 4, 5, 6, then A is the subset of B. Because all the elements of A are the elements of set B, therefore A is the subset of B and it is denoted as A is the subset of B. This is how we are going to represent a subset. Okay. So usually mathematically we are going to represent a subset as A is the subset of B, like this. So let me take one more example. If A is equal to, if A contains 1, 3, 5, 7, then B contains 3, 5. Then what do you say from these two? This B is the subset of A. B is the subset of A. Because all the elements of B are the elements of set A, therefore B is the subset of A. That's it. Okay. So if all the elements of the set A must be the elements of the set B, means then A is called the subset of B, denoted as A is the subset of B. A is the subset of B. That's it. So the subsets are classified into, there are different types of classification. The subsets are classified into a proper subset and an improper subset. A proper subset means a proper subset is one that contains few elements of the original set. The proper subset means the proper subset is one that contains few elements of the original set. An improper subset contains every element of the original set along with the null set. If all the elements of the set are the elements of the set and also the null set, then it is called an improper subset. That is called as the improper subset. Proper subset means in a proper subset only few elements of the set are contained. So that is called as the proper subset and the improper subset. Proper as well as the improper subset. Now let us take an example for a proper and improper subset. Suppose if A is a subset of B, then the set A does not contain every element of the set B, then set A is called the proper subset. If only few elements of the set A are included from the set B, then A is called the proper subset. Now let us take an example. If A, E, I are the elements of the set A, E, I, O, U, then we can say A is the proper subset of B. A is the proper subset of B. That is, proper subset is denoted like this, and it is read it as A is the proper subset of B. Take one more example. Let us take if A is equal to 1, 2, 3, 4 and another set B is equal to 3, 4, then what do you say? B is the subset of A and this is the proper subset because all the elements of A are not taken, only few elements of A are taken to get a set. So that is B is the proper subset of A. That means a subset of a set A is the subset of a set means then the set A does not contain every element of the set B, then it is called as the proper subset. On the other hand, let us come to the improper subset. What is improper subset? If A is a subset of B, then set A contains every element of the set B, A contains all the elements of the set B, then the set A is called as the improper subset of B. So improper subset is denoted like this, improper subset, and it is read it as improper subset. So A is the improper subset of B. Let us take an example. A, E, I, O, U and A, E, I, O, U. Therefore, A is an improper subset because all the elements of A are the elements of the set B. Now, let us take one more example. If A is equal to 1, 2, 3, 4, another set B is equal to 4, 3, 2, 1. This is an example for a improper subset because here all the elements of A are the elements of set B. So, A is the improper subset of B, denoted as A is the improper subset of. Hope you followed. Okay. Now, let us come to the last concept, that is called the power set. Power set is nothing but the collection of all subset of a set is called the power set. So, denoted as P of A. This is how we are going to represent a power set. So, the set of all subsets of a given set is called the power set. The cardinality of A is n. If A contains n number of elements, then the cardinality of power set is 2 to the power of n. So, if A contains n number of elements, then the cardinality, the number of elements in the power set is 2 to the power of n. As every element has two options, either belongs to a subset or not. So, therefore, the cardinality n of A is equal to 2 to the power of n and the power set is denoted as P of A. Let us take an example. If A is equal to 1, 2, 3, then the subsets, let us write the subset first. The subset, what are the subsets of A? If A contains 1, 2, 3, the subset of A or P of A can be written as first one is the null set 1, 2, 3, again 1, 2, 2, 3, 1, 3 and 1, 2, 3. These are all the subsets. So, null set is a subset 1, 2, 3, 1, 2, 1, 3, 2, 3 and the set itself is also a subset. So, therefore, the cardinality, the number of elements of the set is P of A is equal to 2 to the power of, how many elements are 1, 2, 3, 2 cube. 2 cube is nothing but 2 into 2 into 2, that's equal to 8. See, 1, 2, 3, 4, 5, 6, 7, 8. This is very important concept. So, this you may expect this for the point of examination. Let us take one more example. If A is equal to, let us take A is equal to 1, 2. Write the possible subsets of A means the possible subsets of A is P of A is equal to, first write down the set 1, then it contains 2 and then 1, 2 and the null set. So, these are the 4 possibilities. These are called the subsets and the cardinality, the number of subsets of this is P of A is equal to 1, 2, 3, 4. So, that is nothing but 2 square. 2 square is equal to 4. So, in general, the number of subsets including the null set and the given set will forms the power set, that is cardinality P of A. So, power set means the collection of all the subset of A is called the power set, including the set, null set and the set. Now, let us come to the next important concept, that is the universal set. Universal set means the universal set is a collection of all the elements of problem under consideration. The union of all the sets comes under the universal set. So, that is universal set is a set of set consisting of all the elements of problems under consideration. Now, it is denoted as S or U is called the universal set. Okay. So, this is nothing but the superset of each and every one set. So, the set of set, the universal set is nothing but the superset. Universal set is a set containing all the elements of the problems under consideration. Set of all the sets comes under universal set and it is denoted as capital S or U. Now, let us take for example, let A is equal to 1, 2, 3, B is equal to 4, 5, 6. Then we can take universal set is 1, 2, 3, 4, 5. All the elements of A and B are comes under the set. Similarly, if A is equal to 1, 2, 3, 4, 1, 2, 3, B is equal to 4, 5, 6, then the universal set is 1, 2, 3, 4, 5, 6. This is how we are going to represent it. So, the universal set contains all the entries which we are going to consider under consideration. So, this is an universal set. Okay. So, these are few concepts regarding the set, definition of a set and construction of a set, and then the types of set and the power set. So, that's all regarding today's session. Let us meet with the different concept in the next session. Thank you very much.